Hey guys, I just wanted to put together this quick video about my Catalyst proposal for Hydra as a B2B layer for DeFi, a white paper, and a minimum viable product. So very briefly, I wanted to take the sort of 1,000-mile view. What is this thing? Then I want to go a little bit into why do we want it, why Catalyst is a good fit, why I am a suitable candidate to deliver something like this, what the solution actually entails, go a little bit into the details. I won't go into too much, and then what happens after. So after the period of time that is allocated, the 6 months that is applied for in the Catalyst funding. All right, so let's start with the 1,000-mile view. So what is this thing? So it's a research proposal that has 3 main deliverables. The primary of which is a white paper, which is a research paper to look into the viability of the solution that I'm proposing. So I'm going to be looking at all different kinds of design systems, all types of ways of trying to solve the problems at hand, and evaluating their viability in a solution like this. Is it secure? Is it actually solving the problems that we needed to solve? Is the whole thing going to work? Basically, that's the point of the white paper, along with outlining all of the different choices, all of the different rejections, all the possibilities, and basically proposing a design that could be implemented. The second deliverable is a list of MOUs. Now, what this is, if you're not familiar with the term, an MOU is a memorandum of understanding. It's just a way for a project or a company to indicate intent, basically. So they can basically say that, hey, this is a thing that I think is a good idea. This is something I'm passionate about or want to contribute to at some point. It's not a formal contract that signs, okay, we're going to enter into this agreement, but it's just a very good indicator of intent in a written way that sort of specifies, okay, presume that you deliver this, then we are prepared to enter into a contract that contains these different kinds of clauses. So that's the general point of an MOU. Now, how this works in the current case, the goal of the proposal and in particular this deliverable is to split the DeFi space into different verticals. So basically you'll have a DEX vertical where you would have your Wi-Fi, Wing Riders, Sunday Swap, Min Swap, all these DEXs. You would have a lending vertical where you would have projects like LendFi, Liquid, Meld, that deal with lending and borrowing. You would have an Oracle vertical with OrcFax and Charlie 3, and as well as an auxiliary vertical that I'm just taking into consideration, which would be stuff like synthetic assets, Indigo protocol, JED, trading protocols, maybe yield maximizers, that kind of thing. So basically just auxiliary functions, not the primary functions to make the DeFi stack work. So the point of the list of the MOUs is to hit at least one actor in each of these verticals. So get hopefully a list of signatures of these MOUs for each of the verticals. Ideally, many, at least one from each as a deliverable. The benefit of having this is, first of all, you're showing that, okay, with the current actors that have actually shown that they are interested in pursuing this, we're able to deliver and, basically develop and deploy a full stack of this product. So if we have all of these partners or all of these projects that have signed up for this list, if all of them actually commit to the thing that they're saying that they're willing to commit to, then we will be able to deliver the full stack. Because the point of the thing is not as an application specific protocol, but more as a DeFi platform in which these actors are able to carry out their procedures. So finally, we have a proof of concept or a minimum viable product. This is a very simplistic sort of application. We'll get into sort of what exactly it is and why it actually fits into the deliverable and the protocol as a whole. But basically, the proof of concept is just a proof of concept of the interaction pattern between users and this thing. So the actual head itself is going to be a protocol-to-protocol communication layer. So the DEXs would talk to each other, the lending protocols would talk to the DEXs, all of these DeFi protocols would be communicating directly with each other and hosting the Hydra nodes required to do this. The way that users would interact with these things, so if you want to do a swap, if you want to borrow, if you want to do any of these products, that's the point of the proof of concept, to sort of show the type of interaction pattern that I'm going after. Why do we want it? There are very many reasons that we want this. So first of all, just the base features of Hydra have a couple of really good benefits. I'll go over first of all the features and then sort of what that actually unlocks. So one of the prime features is the instant finality. The higher throughput, you can reach very high TPS, although it's not the most important metric of them all. It is still a very important metric when it comes to time-sensitive applications. No transaction fees. You can configure the ledger as you want, so you can have no base transaction fees, meaning that the whole system can be much more capital efficient. You can have different transaction size caps. When the MELD protocol was delivered, one of the issues that we ran into when I was contributing to that was that we hit the memory limit cap of transaction sizes that will actually fit into a block. So the batching script, we had to do some trade-offs. There were some features that we had to cut, and we had to do a trade-off between number of pools available, number of requests that we could batch in a single transaction, and the features that we actually had in the transaction. Finally, the Hydra team is working on basically creating a set of transactions that can be submitted as one, with sort of one big transaction with a lot of following ones that can be submitted as a single transaction into the head. So what that would actually entail, because of the determinism of Cardano, you could actually do flash loans inside of Hydra with that kind of setup. They are working on that, and I'm confident that by the time that this is actually researched and developed and ready to deliver, that feature will be enabled as well. So what these features actually unlock in terms of products, in terms of things that you can use and make use of, is you could have much more efficient arbitrage, which means higher price stability, which means much more robustness of the whole ecosystem in terms of avoiding cascading liquidations, these kind of situations that are not ideal for anyone. You'll get much safer liquidations, meaning that the actual liquidations in a lending protocol, for example, will happen on time. You'll be able to swap on either side. You'll be able to do all of these things that actually secure the depositors in the first place. In addition to these sort of prime security features, you will enable a much larger product portfolio to be made in collaboration between these protocols. So by composing the different types of transactions from the different protocols, you can actually make a lot more products that aren't available today for various reasons. You could have much better yield optimizers, automatic yield harvesting and reinvesting on your behalf, these kinds of things. Because of the capital efficiency, those kinds of things are actually possible to do. You can enable products like leverage trading and derivatives if you're familiar with centralized exchanges and sort of the product offering that they have. So the next question is, why Catalyst? So there are many ways to fund a project like this, or try and get funding for research. I do think that Catalyst is a really good fit for this, just because it has to do with DeFi on Cardano, improving the whole space for everyone, and using Catalyst funding, especially for the research stage, I think is more fair than asking any individual project to fund a research project like this, which may or may not result in a positive positive outcome. The end result of this might be that, okay, the conclusion is this is not viable, for all we know. If a single project, if one of these DEXs or lending protocols or oracles or any of these is funding a research project like that for 6 months or whatever, it's a large investment for a small company, right? So a source of funding like Catalyst is much more fair, and it benefits everyone, and it also allows all of this to be committed to open source development. So one of the points that is actually brought up in the MOUs that the projects and the verticals are asked to sign is to help develop a open interface that basically abstracts away all the business logic of the role that they're fulfilling. So for example, a DEX can have different kinds of things going on in the background, but their core features, swapping and providing liquidity, these kinds of things, is going to be sort of abstracted into an open interface, so that any protocol that actually adheres to this interface should be able to participate in ahead. And that kind of approach is much more viable with a funding source like Catalyst. So the next question is, why me? Who am I, and why am I suited to deliver on this research proposal? So I'm not going to go into all the details of my background. If you're interested or curious, reach out to me. I'm more than happy to talk about anything. But basically, before I joined the blockchain space, I did a bachelor's degree in pure mathematics. I focused on a topic of geometry and logic and algebra. I really fell in love with topology, which actually I started out studying physics, but transitioned into pure maths after a semester because I just fell in love with the field, and real analysis, topology, that kind of thing was really my jam. After my bachelor's degree, I did a master's degree in pure mathematics and mathematical logic at the University of Manchester, which was a really interesting topic. I really dug into the foundations of mathematics, and through Gödel's completeness theorems, incompleteness theorems, the continuum hypothesis, which was sort of my entryway into this field, because my background in topology, I really fell into mathematical logic through that direction, and I sort of ended up at the edge of reason, as you may say. It's a really interesting field. It's a rich and diverse field. It really gives you some deep insights into what happens, what reasoning is all about, the connections between geometry and logic, all of these things that are just amazing. So after my master's degree, I took a second bachelor's degree, actually, because I wanted to get my hands dirty. I wanted to get some ways to apply my pure mathematics and mathematical logic background, get it actually out into industry rather than going into teaching. So I took a bachelor's degree in computer science. Tried to get as much sort of hands-on as I could with different coding languages, database designs, worked a lot in Python, MATLAB, all kinds of things. So I did a lot of time series analysis and some, tried to apply some of the math that I knew from my master's degree in my bachelor's thesis. So after my student years, I went into data science for a couple of years. And as a part of that, so my first job as a data scientist was working on with natural language processing, making statistical reports based on company reports. After that, I worked with that for a brief period of time. After that, I went into the maritime industry, where I did a lot of algorithm design. And basically what was, industrial research and project management. So after that, I actually joined the blockchain space in 2021. It was completely by random. I ended up finding Igon, who was trying to transition their system from Ethereum over to Cardano. And I got on board with the team, started out as an algorithm designer, had a look at their existing system and their existing solution. It had flaws here and there, and it wasn't suited at all for Cardano. So we did basically a ground up redesign of the whole thing, including token utility and a completely novel file distribution algorithm. The algorithm that I developed, that I called the random mask sharding algorithm, is currently in the beta testnet for Iagon's node solution, which is fantastic. It's really cool to see this in the works. Personally, I think it's for Iagon's solution, a storage solutions for larger files supposed to be kept on the network for a longer period of time. With a subscription service, the actual file distribution algorithm is an improvement in terms of performance and scalability and security over the IPFS method of the distributing files across networks like that. So yeah, that was pretty exciting days actually, and I'm very happy that the team has now been able to deliver the based on those designs that I made. And I'm still involved with Iagon to a certain extent. I'm helping out with the Stature and Fluxion, which are some of their Catalyst proposals that I also recommend you go and vote for. After that, I joined Meld. Technically, I started my own consulting firm and took on Meld as my first biggest client. I worked there as a product manager for about a year and a half. So at Meld, I did a few different things, the principle of which was help the requirements capture, product design, and product requirements definition of the lending and borrowing protocol, along with the actual development and deployment of that protocol onto the testnet. It was deployed in January 16th, 2023. So following the deployment, I found a vulnerability, started the collaboration with IOG to find a viable solution, and in the interim, Meld has moved on to focus on more immediate deliverables, which is understandable under circumstances, and yeah, that's basically what led me to the current situation where I have submitted a Cardano improvement proposal for a transaction prioritization system that does not entail or require a fee market or a tiered fee system. I have another video of that if you want to check it out. It's on my channel. In addition to this, the current Catalyst proposal that we're talking about. Okay, so what is the solution? First of all, this is a research project, so obviously there's going to be a lots of to be decided and to be evaluated design patterns here. So nothing is sort of fixed in place. These are just general ideas and directions that I'm currently pursuing, but that I want to pursue in full, provided the Catalyst vote goes through. So the point of the or the main crux of the solution is a protocol to protocol communication layer, or basically a B2B solution, business to business. What this means is that you'll have different protocols having Hydra nodes operating a Hydra head and communicating between each other, sending messages, and basically facilitating DeFi interactions. So these protocols might be, different DEXs, lending protocols, oracles, and say synthetic asset minters. So this is an example configuration of a head. So you would have these different protocols having a communication layer between them, all facilitated by the oracle, that allows them to execute trades between each other very, very efficiently, very quickly. So how does the customer fit into this picture? So the way that the customer would fit into this is that they would actually use what is called a delegated head, which means that you go to your different DEX, let's say that is this one, And basically you open your browser and you connect to their Hydra head or Hydra node by proxy. Basically, you connect to their website, you authenticate with your wallet, and then you send requests that are signed using your keys and your authentication to this, to this protocol. Say that it's this decentralized exchange. They relay this message into the head that is then signed by all of the other participants. So that is what's called a delegated head. What this means is that you personally don't have to spin up and have your own Hydra node running, because that requires some infrastructure. You need to have a full Cardano node. You need to have a little bit of, constant uptime. Basically, you need to do a lot of verification. That's not really suited for mass adoption or for regular users. So by having this kind of interaction pattern, this delegated head, you're able to participate and the protocols are able to communicate between themselves. So how would that actually work in terms of, if you're used to regular swaps using DeFi on the layer 1, it works a little bit differently. So a convenient analogy is actually a centralized exchange. So in a centralized exchange, if you've ever used a centralized exchange, typically what you'll do is you'll have a blockchain and you'll have an account that you interface with a centralized exchange through their website, for example. You go to Binance.com, you go to whatever site.com, and you're able to deposit assets into the centralized exchange, into your account, right? So you have from your blockchain into the centralized exchange, you have a deposit function. And then when you do the trading, when you're finished, you want to withdraw your assets. Either you can take them out as fiat, or you can take them out as, back into crypto, back onto the blockchain that you were originally at. So that's a withdrawal function, right? So the actual trading that you're doing inside of the centralized exchange typically isn't moving the assets that you have deposited at all. Typically what will happen instead is you'll make a deposit and then they will basically give you these IOU tokens, or sort of, a sort of representation of value inside of the exchange. And then they'll let you do trading with that. So they're not actually, submitting transactions to the blockchain every time you sell, every time you buy, whatever. They're actually just moving around these pieces of, digital paper that represents ownership. So what that means is you're doing all of this trading inside the centralized exchange, and then you can redeem that afterwards. A similar kind of situation is what I'm proposing here, that inside of the Hydra head, so instead of the centralized exchange, here you would have the Hydra head with all of the protocols operating it. You as a user would make a deposit on main chain to deposit contract, and then inside the Hydra head you would get a representative token, or a representative virtual representation of the assets that you have deposited, verified by the oracle, right, inside the Hydra head. Then you can do all the trading with the representational asset. So we can think about it like a wrapped asset. You can think about it whatever way you want, but it's not the actual asset. The actual asset is safely stored on the blockchain. It's not going inside the Hydra head. It's only the representation of value that's going inside the head. Now, by using wallet authentication and basically all of the benefits of blockchain or the Web3 authentication space, you're able to verify that the actors inside the Hydra head are not able to spend your funds, because the way the Hydra head works is exactly the same as the way that the main layer works. All the signatures have to be the same. It's basically the same sort of safety mechanism, except it's just a different kind of consensus mechanism. So another topic that's very important, when it comes to the solution is, okay, how do we deal with decentralization? If you have 5 different protocols inside the head, that's not particularly decentralized. One, caveat or sort of benefit to this approach is that inside Hydra, you need full consensus. So if the if the participants in the head are trying to do some shenanigans, they actually need everyone to sign off on that transaction. So you only need one participant, to be honest, in order to flunk an attempt like that. Furthermore, you have this concept of horizontal scaling. So if you take the, let's go to the previous page, go to this page. So in this case, right, you have a oracle that's present in the head. Now, oracles, especially decentralized ones, are typically, they have their own sort of consensus mechanism going on outside of whatever it is that they're dealing with. So this oracle node would probably be connected to a network of other oracle nodes that have their own sort of system, their own sort of consensus mechanism that ensures that all of the validation that is done or performed by an oracle node is checked by other oracle nodes as well. So it's double checked. It's not possible for a single oracle node to sort of fake this data. So in this case, you can make an argument that the decentralization scales horizontally. So the decentralization mechanism that the oracle node has, in addition to the actual Hydra head, translates into the decentralization of the Hydra head. Similar things for the other participants as well, if they want to have a more decentralized node operation. So an important key here as well, especially as it pertains to the blockchain space, is transparency. There is a tool called Kupo which allows you to look at the ledger that is or it's basically a way to look at the current state of the ledger. Kupo does actually work reasonably. It's fairly integratable with Hydra. There is already a pull request by Sebastian and Kators to fully integrate Kupo into Hydra, which will allow the protocol to set up a public-facing interface with that, so anyone can go in and look at the ledger state at any time to have the full transparency, similar to the actual blockchain itself. In addition to this, I know that Pi and SundaySwap have a Catalyst proposal for a similar sort of solution as well that allows other people to look at and monitor what's going on inside the head. A open problem, or something that needs some serious considering, which I haven't done yet, it's part of it's very much intended to be a part of the research, is to investigate thoroughly the incentive structures of such a system. So will this allow for healthy competition? Will there be situations where nodes will try and deny transactions because they don't want traffic to other nodes? Are these things going to happen? If so, how can we change the head topology to sort of accommodate and avoid that? I know that George from M Labs has a auction model that he has made for using Hydra that circumvents this, in a clever way. So, something similar might be required in this scenario, but, it needs some thorough investigation. So the last question is, what happens after? So the white paper is delivered, and either it's positive, this can be done, or it's negative, this cannot be done for whatever reason. At that point, if the answer is actually negative, this cannot be done, okay, it's probably a very good reason. You typically design around certain things or shortcomings, but if it's actually a legit reason why it cannot be done, that's that. It's only really the Catalyst funds were spent towards this, and I think that's still a worthwhile result. Negative results are also very valuable in the field of science. In the other case, though, if it is actually viable, if it's showing to be a promising direction, then the list of MOUs is a very good candidate list for the place to start for bringing projects on board. They might have to do certain changes, small adjustments to their existing code base to make it actually, work. The way Hydra works, you can actually bring the smart contracts directly into the head and, do operations as normally, but, with the changed design where, you're not actually trading the tokens directly, you're, trading the ownership of the tokens. You don't really need batching solutions because of the instant finality. There are certain changes, that are sort of just natural based on the design of Hydra. So it's only natural that certain changes need to be made to the protocols, but they have, the core designs and the core, business designs, as well as, the liquidity pools and all of these things. So it should be reasonably straightforward for them to go into the implementation stage of this. So after the delivery and the implementation, there's still things going on. There's a lot of development in the Hydra ecosystem. I mentioned George from M Labs. He's working on a very exciting thing called Hydra Zoa, which is just a simplified version of Hydra, which will work better towards, products like this, where communication between the main layer and the Hydra head has to be more flexible, and it's quicker to spin up and close down heads. Also, I know that the Hydra team are working on a lot of different very exciting features, cross-head communications, different head topologies. All of these things are going to really impact the way that this thing can be structured and delivered. So I hope that answers most or all of your questions. If you still have questions, leave a comment below. Follow me on Twitter, reach out there. You can reach me on Telegram. I'll leave links to my socials and the Catalyst proposal in the link. And, feel free to vote or downvote as you see fit, but please do participate in the governance and, the voting on Cardano. All right, that was it for me. Thank you very much.